So this is the fourth or fifth lecture? Fourth, I think. Okay, today we start with a null semigroup. Null semigroup. A semigroup S with zero, or you can say zero semigroup with zero, जो कि ये एलिमेंट है जिसको ज़ीरो से ही डिनोट करते हैं, is said to be a null semigroup. Is said to be a null semigroup if for all xy in S the product is equal to 0. That means product of any two elements is equal to 0. Product of any two elements is equal to 0 in this null semigroup. Next, we define left zero semigroup. Left zero
Sir, null semigroup.
Okay, it is a null semigroup. Okay, it's semigroup actually, sorry.
पहले भी
It's a semigroup.
so पहले भी definition के था.
Okay, आप semigroup लिख दीजिए. It is not a semiring, it's a semigroup. Now left zero semigroup. If S is a non-empty set, S is a non-empty set. If S is a non-empty set, and we define a multiplication. Define a multiplication on S by AB is equal to A for all AB belongs to S. अगर S कोई नॉन एम्प्टी सेट है, इस पर मल्टीप्लिकेशन ऐसा डिफाइन करेगी AB is equal to A for all AB in S. We can easily verify that this is a semigroup because this operation is obviously a binary operation because the product of two elements is again in S. Okay. Also it satisfies the associative law that you can easily verify. अगर आपको associative law चेक करना होगा, associative law in this case, associative law, तो इसके लिए आपको तीन एलिमेंट्स लेने हैं सेमीग्रुप एस सेट एस में. then ABC, this is equal to product of two elements is equal to the first element by definition, it is equal to AB. Again this AB is equal to A, and ABC, product of these two elements, it's equal to A. So thus ABC is equal to ABC. So therefore this S is a semigroup. S is a and this semigroup is called a left zero semigroup. Left zero. तो लेफ्ट जीरो क्यों कहते हैं इसको? एक्चुअली इसका हर कोई जो एलिमेंट है ना वो लेफ्ट जीरो. आप कोई भी एलिमेंट ए लीजिए, तो रीजन why we call it a left semigroup, because can easily verify that every element of this semigroup is a left is left zero. Every element is left zero here. So because the reason why it's called a left zero semigroup, because for any a b belongs to S, the product ab is equal to a. So that means this a is actually left zero. This a is a left zero semigroup. So similarly we can define right zero semigroup. Similarly we can define a right zero semigroup where the multiplication is defined by, operation means here multiplication, जो मैंने पहले कहा है, where the multiplication is defined by AB is equal to B for all AB belongs to S. So this is definition of left zero and right zero semigroup. So another example of a semigroup which is if this S is equal to the, say it's equal to closure interval 0 1. So one operation is a usual multiplication, but we define operation by here define xy is equal to minimum of x comma y, and you can easily verify this multiplication. If we define the multiplication like, it's obviously closed because minimum of x comma y is again in the same set as, so it's a binary operation, and also it is associated because minimum of x comma y. So reason why it's associated, because this minimum of x comma y, okay, then z, it's like this actually, minimum. It is same as minimum of this x, minimum of x, and here we choose this is minimum of y z, and this can be easily verified. So that is x y z is equal to x y z. So this is a semigroup है, और अगर आप देखोगे इसका जो जीरो एलिमेंट है ना वो जीरो है, because if you find the multiplication 0 into y, 0 into x for any x in x, it's equal to minimum of 0 comma x, and that's equal to 0, and x into 0 is equal to minimum of x comma 0, it's equal to 0. So this is a semigroup with 0, and that's here this 0 element. Okay, also one acts as an identity that can be easily verified. Also 1 into x, which is equal to minimum of 1x. X is always lesser or equal to 1, so its minimum is x, and x1 is equal to minimum of x1, which is again equal to x. So thus S is a semigroup. S is a semigroup with 0, 0 and identity 1. Okay. Another example you can take, let's take this set S, which is equal to 0, 1, 2, 3. This with the operation plus. Okay, is it a semigroup? The set of whole numbers with binary operation plus. ये semigroup है ना? So this is a semigroup. इस सेमीग्रुप की आइडेंटिटी क्या है? 0. Yes. इसकी आइडेंटिटी हाँ, कोई बताए इसकी आइडेंटिटी क्या है इस सेमी ग्रुप की? अच्छा, इसका जीरो एलिमेंट क्या है? इज इट अ सेमी ग्रुप विद जीरो? हाँ, कोई तो आंसर बताए इसका। आप लोग क्लास में ही हो ना? कीप योर कैमरा ऑन। हाँ, कोई ये बताइए, ये जो सेमी ग्रुप है ना, जो मैंने यहाँ पर लिख दिया होल नंबर्स विथ एडिशन, इसकी आइडेंटिटी क्या है इस सेमी ग्रुप की? जीरो इसकी आइडेंटिटी है। ओके, इसका जीरो एलिमेंट कौन है?
जीरो एलिमेंट नहीं है उसमें।
जीरो एलिमेंट नहीं है। सो दिस देन दिस एस इज ए सेमी ग्रुप। एस इज ए सेमी ग्रुप। सेमी ग्रुप। ओके, मैं हमेशा रिंग लिखता हूँ, बोलता हूँ मैं सेमी ग्रुप पर लिखता हूँ रिंग। दिस एस इज सेमी ग्रुप with identity 1 that's equal to 0 here. Okay. And this is not a zero semigroup, huh? It's not a zero semigroup. It is not a zero semigroup. Okay, इसके पास जीरो नहीं है इस semigroup के पास। So without zero. So now we define product of two sets in a semigroup, जैसे आपने ग्रुप्स में डिफाइन किया है ना। if A and B are subsets of a semigroup S, then we define the product AB is equal to AB, where A is in A, B is in B. And also we define A square. What's A square? A square कौन सा सेट होगा इसमें? it's obviously a subset of S, because A is in A, B is in B, so both the elements belongs to S, so it means that the product also belongs to S. So what's A square? A into A, ये कौन सा सेट होगा?
A squared.
Not, it's not A square, it's A1 into A2, where both A1 and A2, they both belong to A. Okay, so this is A square, and one can easily verify that. One can easily verify that this it follows from the associative law A B C is equal to A B C, where these are the subsets of S, where A B C, they are all subsets of S. They are all subsets of S. Okay, if we have a singleton set, suppose B is a singleton set. If B is a singleton set, then we use the notation AB instead of A into set B. So that is this AB means is equal to AB such that A is in A. So like this, this is the notation for us. अगर आपके पास एक सेट, अगर जो सिंगलटन सेट आपके पास होगा, and if we have a semigroup without identity, if A is an element of a semigroup S, if A is an element of a semigroup S, then SA, what is SA? SA means this set SA, where S belongs to S. If A is an element of a semigroup S without identity, okay, without identity, इसके पास identity नहीं है, without identity, then SA, which is called this set, may not contain the element S, or need not contain the element A. हाँ, अगर S में आइडेंटिटी होती है ना, उस केस में डेफिनेटली A को कंटेन करता, क्योंकि S का वैल्यू ऑफ 1 लेते, बिकॉज S वेरीज ओवर S. अगर S का वैल्यू 1 हम लेंगे, अगर S में आइडेंटिटी होगी, तो उस केस में S A जो सेट है आपके पास, उसमें एलिमेंट A होता. मगर अगर आपके पास जो S जो सेमी ग्रुप है, इफ इट्स अ सेमी ग्रुप विदाउट आइडेंटिटी, देन S A may not contain this element A. So also we make the use of following notations. Also we make the use of following notations. What are the notations? The first notation is S1A. What's S1? S1 means a semigroup S with adjoining an identity 1. Okay, S में identity नहीं है, मगर हमने adjoin identity की है. It's equal to SA. इसका मतलब क्या है? It's equal to SA. ऐसे आपने already define किया है. Union A. अब क्योंकि इसमें S1 A में अब A भी होगा, एक तो ऐसे भी होगा सारे वो सारे एलिमेंट्स हो गए ऐसे टाइप के, और इसमें A भी होगा बिकॉज S1 कंटेन्स आइडेंटिटी 1। इसी तरह से आप ये डिफाइन कर सकते हो, इट्स इक्वल टू AS यूनियन A, AS यूनियन A। और आप ऐसा भी एक सेट डिफाइन करते हो S1A S1, दिस इज इक्वल टू एक तो SAS सारा होगा SAS यूनियन, अब अगर मैं इस S1 में यहाँ से S1 में अगर आइडेंटिटी लूँगा तो ये AS हो जाएगा, यूनियन AS यूनियन, अब यहाँ से अगर मैं इस S1 में आइडेंटिटी चूज करूँगा तो ये S से आ जाएगा, एंड यूनियन A। तो S1A S1 ये सेट है, SAS यूनियन AS यूनियन SA यूनियन द सिंगलटन A, these three sets. Now what is this SAS? Where SAS क्या है? SAS it's equal to SAT, where ST both they are the elements of S. This is SAS. So they are all subsets of S actually, but they may not contain identity. So S1A जरूरी नहीं कि ये identity को contain करे, A को ये contain कर रहा है but it may not contain the identity element. So clearly S1A S1 and S1A S1 need not contain the identity. They may not contain, but they are all subsets of S actually. Now let's define the group in terms of semigroup that you were well familiar with. If S is a semigroup, if S is a semigroup, if S is a semigroup, has the property, अगर इसके पास ये property होगी, has the property, as a property for all A belongs to S, AS is equal to S, and SA is equal to S. अगर इसके पास, इस सेमीग्रुप के पास ये प्रॉपर्टी अगर होगी, AS is equal to S and SA is equal to S. SA और AS आपने ऑलरेडी डिफाइन किया है, ये कौन से सेट्स हैं. Then we call this, and we call it a group. We call it a, but this is not the usual definition of group. Usual definition of group is it's a semigroup, and it contains the element identity and the inverse of each other. That's the usual definition of group. And you can easily verify that both are actually equivalent, that you have already done in your BSc course. Actually this is this one is actually, this equation has a solution ax equal to y in S, and इसका मतलब ये है कि x equal to y जो इक्वेशन है उसका सोल्यूशन होगा S में. तो ये आपने ऑलरेडी किया है BSc में ना. A semigroup S is a group if and only if both these equations have a solution in S. ये वही है एक्चुअली. और आपको एक्चुअल डेफिनेशन जो ग्रुप की है वो आपको पता है क्या है. सो इट्स अ क्लोज्ड, इट हैज it is associative and it possesses identity and inverse of each element exists, so that you know. Next we define a group with zero. Let's call it zero group. If G is a group, if G is a group, then G0 हम ज़ीरो इसके साथ एडजॉइन करेंगे, G0 which is equal to G union 0 is a semi group. एक ग्रुप नहीं है, हमें पता है, हमने ऑलरेडी किया है, is a, but it's a semi group, is a semi group, and we call it a zero group, and हम इसको कहते हैं zero group. We call it as zero group. इसको हम zero group कहते हैं. So zero group is not a group, it's actually a semi group. We call it a zero group, or a group with zero, or a group with zero. Group with zero. Next, we have following proposition. तो नोटेशंस आपने सारी देख ली है क्या है, ये थ्रू आउट ऑफ दिस कोर्स नोटेशंस का यूज़ आप करोगे कि AS, SA, AS1, S1A, जो भी नोटेशंस आपने लिखे, जो भी आपने डिफाइन की है ऊपर, ये सारी नोटेशंस आप याद रखिए. First, we have following proposition: a semigroup with zero. A semigroup with zero. आपके पास semigroup S है with zero. A semigroup with zero is a zero group. ये zero group होगा. Is a zero group. Is a zero group. If and only if for all A belongs to S minus 0, because S is a semigroup with 0 non-zero element of S. For every non-zero element A of S, we have AS is equal to S and SA is equal to S. A semigroup with zero is a zero group if and only for all A belong. अब zero group क्या होगा? Zero group वो है अगर zero group एक semi group ही है ना, zero group is a special semi group. तो zero group हम कब इसको कहेंगे? अगर हम इसमें से zero को बाहर निकालेंगे ये group बन जाए. तो zero group की definition ये ना, हम group के साथ adjoint zero करते हैं, जो आपने ऊपर definition लिखी है. तो that means अगर हम इसमें से इस जीरो ग्रुप में से जीरो को बाहर निकालेंगे, ये क्या रहेगा? ये सिर्फ जी रहेगा ना, जी इज ए ग्रुप. तो जीरो ग्रुप की डेफिनेशन यही है, जीरो ग्रुप से अगर आप जीरो को बाहर निकालोगे ये ग्रुप बनना चाहिए, तब जाके हम इसको कहेंगे ये जीरो ग्रुप है. तो वही आपको प्रूव करना है. इट्स ए सेमी ग्रुप विद जीरो, आपके पास है सेमी ग्रुप विद जीरो. अब आपको प्रूव करना है ये जीरो ग्रुप है. जीरो ग्रुप मतलब अगर इस सेमी ग्रुप से आप जीरो को बाहर निकालोगे ये ग्रुप वो ग्रुप होना चाहिए. इफ एंड ओनली फॉर ऑल ए, फॉर एवरी नॉन जीरो एलिमेंट ए इन एस, वी हैव एस इज इक्वल टू एस एंड एस ए इज इक्वल टू एस. सो लेट्स प्रूव दिस proposition. Proof. So first we assume that this S is a zero group. Assume that S is equal to G0, which is equal to G union 0 is a zero group. ओके आप पहले अज्यूम करोगे कि आप मान लोगे पहले कि ये जो S है ये जीरो ग्रुप है. देन बाय डेफिनेशन G इज ए ग्रुप. then by definition this G is a group. So therefore for all A belongs to G, AG is equal to G and GA is equal to G. ये भी आपने ग्रुप की डेफिनेशन देखी है, हमने ग्रुप को ऐसे ही डिफाइन किया है. AG is equal to G and G is equal to G. Now, but we have to prove that we have to prove this one. If G is a group, then for all A non-zero element, AS is equal to S and SA is equal to S. ये हमें चाहिए. So let A belongs to S minus 0. S में से 0 बाहर निकालोगा. That's your G actually, because S is equal to G union 0. तो S में से आपने 0 को बाहर निकाले, G के बराबर है. Then AS, what's AS? AS is equal to A. What's S? S is S union 0. S is G union 0 actually. It's G union 0, and that you can easily verify that it's equal to AG union 0. What's AG? AG is same as G. It's G union 0. What's G union 0? That's equal to S. So therefore AS is equal to S. अब आपको चेक करना है एस ए जो है वो भी किसके बराबर है, वो भी एस के बराबर आना चाहिए. सो अगेन इसमें आपने क्या देखा, एस. अब आपको ऐसे निकालना है. अगेन this SA which is equal to G union 0 A, that's equal to GA union 0 which is equal to G union 0, and that's equal to S. So that proves this part. Now conversely, assume that for all A belongs to S